Okay, it's been a long time. How's everybody doing? Yes, we are back to programming challenges. So this is going to be the first video after my long halt from my last programming challenge. Hopefully this one will go well. Let's see. 30 minutes start. Okay, so nested list weight sum. Second. Don't know how hard was the first one, but let's see. Given a nested list of integers, return the sum of all integers in the list weighted. Geez, I should have taken a nap. Return the sum of all integers in the list weighted by their depth. Each element is either an integer or a list, whose elements may also be integers or other lists. Different from the previous question where weight is, not sure what the previous question is, but I guess it doesn't matter here. Different from the previous question where weight is increasing from root to leaf. Now the weight is defined from bottom up. For example, the leaf level integers have weight 1 and the root level integers have the largest weight. Not quite sure what they mean here. So input is you have one array with 2 subarrays and 1 integer, and the output is 1. Now the explanation is 4 ones at that 1 and 1 2 and that 2. So 4 ones and that 1 and 1 2 and that 2. Well, let's take a look at another example. So 1, and then we have 4, and then we have 6 inside of the 4 array, and the output is 17. And the explanation is 1 1 at that 3, 1 4 at that 4, and then 1 6 and that 1. So 6. The reason why that it looks like the reason why 6 is at that 1 is because 6 is basically the first child of the array of 4. So we have 1 times 3 plus 4 times 2. 6 times 1 equals 17. And I wasn't quite sure about the first example. So if you take a look at the 1 1. 4 1 and that 1, so which means that among these two subarrays, ones are all that 1 and 2 at that 2. I'm still a little bit confused with the first example. I can understand this one, but so wait, that's it? Huh. Interesting. Okay, so let's see what they have here. So this is gonna be tough. 26 minutes. This is the interface that allows for creating nested lists. You should not implement it or speculate about this implementation. So we have a nested integer interface, constructor initialize an empty nested list, and we have another nested integer. So this is a constructor, and we have a constructor that initializes a single integer. And return true if this nested integer holds a single integer rather than a nested list. And return the single integer that this nested integer holds. If it holds a single integer, return null if this nested integer holds a nested list. And then set this nested integer to hold a single integer. So I also have set and get, right? You also have set and setter and getter. And we have set this nested integer to hold a nested list, and adds a nested integer to it. A nested integer to it. So public void add, we have nested integer. It's a class or the object of nested integer. So ni nested integer. And we will return the nested list that this nested integers holds. If it holds a nested list, return null if this holds a single integer. So basically you have methods that tells tell the parameters apart, whether they are a nested list, whether they are a list or just an integer. I'm still trying to figure out why the first example is 8. So let's see what they want us to write here. So we have this method is def, so okay, and then you have a parameter which is list nested integer nested list. Okay, so well, on the top of my head right now, I can think of using a depth search, because it looks like this is a very typical depth search question. Well, the problem is that we need to understand this question thoroughly before we move on. So I understand that 1 is at depth 1. Well, 1 and depth 3, this is a little bit confusing. Oh wait, they say this is from bottom up, right? So okay, that makes a little bit sense. Now the weight is defined from bottom up. Okay, so one and depth 3. So this is depth 3. And 1 4. So let me read the question again. Given a nested list of integers, return the sum of all integers in the list weighted by their depth. The sum of all integers in the list weighted by their depth. Okay, so this is easy to understand. It's just you do have to do sum like this, right? This is the point. And each element is either an integer or a list whose elements might also be integers or other lists. So from bottom up, now my understanding is, since the weight is defined from bottom up, then so different from the previous question where it was in question, now the weight is defined from bottom up. So the leaf level integers have weight 1 and the root have the largest weight. The root level integers have the largest weight. So this is root. This is the root of this tree. And then the leaf level, is 1 and 1. So are you talking about this is a tree? So if this is a tree, then 1 should be level 2, level 3. And then 4 is at, well, have 3 levels here, right? So you have 3 levels here, you have 2 levels here. 1 it's at level 1, and then 2. Okay. All right. So it's based off of the layer. It's based off the layer of your current array. So your array is outside of. It's like the second layer. Your array is like the second layer of the root array, which means that you are on second level, which means that's the leaf level. You only have weight 1. So you have 4 ones at level 2, which has a weight of 1. Because at the lowest level, you will only have a weight of 1. And at the root level, you are, which is essentially the second level, you have a weight of 2. And you have 2, so you have 4 times 1 plus 2 times 2, which is equal to 8. So that makes sense. And then for 1, 4, and 6, right? 6 is inside of 4, and this subarray is also inside of this root array with 1. So 6 is actually the third level down from the root array. So a 6, obviously, well, because you're the lowest weight, since you're at the lowest level, you'll have the weight of 1. So I think the first thing we need to do is we need to know how many levels we have. How many levels we have. And well, essentially, do we really need how many levels we have? Because as soon as we reach the bottom, we can just do a recursive call back to the higher level and increase the weight by 1. So we actually don't need to tell how many levels. We don't need to see how many levels we have. We just need to do a depth search. And once we reach the bottom, we will increase the height. So if we switch once reach bottom, when we reach the bottom, will increase weight by 1. So we don't need to know how many levels we have. But we'll just do a depth search until we hit the bottom, and then we'll recurse it back. So now the question becomes the implementation. So there are 2 searching techniques in algorithm. So one is breadth search, and the other is a depth search. Now for breadth search, you usually do a queue, and then you attach the head and append the tail to traverse a graph with breadth search. And then with depth search, in this case, it's a different beast, and usually the implementation is a little bit more complicated, which is right now I'm feeling a little bit concerned because I haven't touched breadth search for a while. So let's see. And so for breadth search, we need to have a termination, right? Since we are traversing a nested list, we need to know when to stop. So first of all, we need to know if it's a single integer. What just happened? So if it's a single integer, then it means that we can stop, right? If it's a single integer, then we can stop. But we need to look at the weight, right? So first of all, I think first thing we need to do is to see if there is any other. So we'll traverse our current array, and if there is no nested list, then it means that we have reached the bottom, right? It means that we have reached the bottom. So we can just add it up and then return the weight. So, but then we have to report the weight, the current weight we have. So we can write, I think we can write a method assuming that the current array doesn't have a nested list. So, and then we can traverse it back to the upper level. So first of all is we'll need say if nested list. So if not having nested list, okay, so if not having nested list, so we don't have any nested list, we just have integers. So we can safely add this up. So say we can have a integer to add it up. For each nested integers. Now, since this is the very bottom of the tree, so we can pretty much assume the weight is going to be 0. So sum will be just n nested integer. Let's see their APIs. There must be a get, right? Get integer. Get integer, okay. Get integer. Okay, so I think they already have an API to say nested integer, get integer. If a return holds a nested list, sets this is to hold and set this nested integer to hold a nested list, and add a nested integer to it. Return the nested list that this nested integer holds, if it holds a nested list. What the fuck is this? And return null if it holds a single integer. So return null if this integer is. So there's no way that we can tell. There's no API to tell if this list of nested integers is all integers. So if not having nested list, then sum will add these all up, and then we'll return the sum. So here's the question. I feel like we should return the weight instead of the sum, because a sum can be a global, because we need to know the sum eventually, so why not we just set it as a global variable. So private int sum is going to be 0, and then so if it's not having nested list, then we'll just keep adding the integers, and then return our weight. So we need to know what our weight is. Return the weight. So, and then we'll create a weight. I'm a little bit confused with this. Let's get back to that. I'm not sure whether to return a weight or not. So let's say if not having nested list, which means that we only have integers in this list, then we'll go through the list, add them up to a global integer variable. I'm definitely going to fuck this up. I'm getting rusty. Son of a... Do you guys know any food that is good for for brains, like walnuts or peanuts or something like that? I think I definitely need some brain food. Okay, so if not having a nested list, then we will add the integers up, and then the next step would be, so next step would be, now with this array have subarrays, right? What the neighbor is playing some Bruno Mars music that I can't really focus right now. Okay, focus. Okay, so after this statement, right, we know for certain that this list has some subarrays. So why don't we assume that we have a weight, and then we go over this list, and then we go over this list to sum to add up the sum. So after this, I'll have for nested integer and god damn it, the music is so loud. And then nested list. So now we need to see if it's a integer. If it's a get integer, there's a API that called get integer, right? And we don't know if this holds a nested list. So we'll dot get integer. If get integer is not equal to null, then we can add. Now we need the weight. What is our weight? We don't know, but we assume it's there. Dot. So I'll do a local variable, which is called let's just call int or number. So n dot get integer, and we'll replace this with our local variable, and then weight times num. This will be added to our sum. Okay, and if it's not null, that means that this get integer, it is not null, then that means that this nested integer contains a subarray, which means we need to do another traversal, else we'll have it. So I'm not sure whether I should throw it back to. So definitely inverse. Well, definitely you need to return a sum. So a sum will add a so we'll throw it to a method that does the traversal. Okay. Jesus, can you fucking... The music is so loud. You probably can't hear it because I'm wearing a microphone, but you can tell what they're playing right now. Okay, so you will add the weight if it's not null, which is a single integer, and then you time the weight and plus it to the sum, and then you traverse it back, get the sum back to sum. So I feel like we should pass down, excuse me. So I feel like we should write another method to pass the weight around. So can I write a method that pass not only the weight but also the sum, then pass down the sum, and then also the pass back the sum, and also the what? I'm losing. Fuck. Yep, getting rusty, man. So we need a method, because right now we're missing the weight. We don't know the weight, right? And then we can apparently, I mean, if you return by this, it's going to have a wrong. So we definitely need another method now, which is let's go to private and int and traverse helper. Okay, so traverse helper, which will take in, I'm imagining here, will take in a nested integer, and which is called, let's call it n, and then it will traverse it to see so this part should be here. If not having this, so if not having nested list, which is this one, so if not having nested list, which is n, then we'll add it up, and then we'll return the weight. So what is the current weight right now? We don't know. The current weight is, so I feel like somehow we need to, keep track of the level. Okay, so for if it's not, it doesn't have a nested list n, and for nested integer n and a nested list, we'll have sum plus equal and get integer. Okay, that's good. And then return weight, because we're already doing calculation on sum. So I feel like at the end here we can just return sum instead of doing something else. And then we can do traverse helper. That looks more like it. traverse helper for integer, the get integer if it's not blah blah blah, weight times n. Well, I mean the problem is you don't know the weight here, so how are you going to, well, unless you traverse first, right? You traverse first. So if n is equal to null, god damn it. Okay. So yes, I failed the challenge, and I was reading through this guy's post, and I was actually pretty close to this solution. So I think I might as well just read through his solution and see what we can learn from this. So basically, his thought is pretty much similar to mine. You have to get the number of levels you have. So I think what he meant here is height. So you have to get the height of the tree, which is something that I missed. Well, I did think of getting the height of the tree, but I kept trying to push myself to get the height of the tree with one method. So I tried to push myself to get the height of the tree and get the sum in one method, which is not very feasible. So here he has one method just to get the height of the tree, and the other one is to get the sum of the tree. That divides the problem and conquer them separately. So that's very clean. Now, so let's take a look at the helper function. Takes in the parameter is the list of nested integer. So if the list is null or size is near 0, that means that you have traversed to the end, return 0. And now here you set max as 0. And this is where you do the traversal part. So for each nested integer in this list, excuse me. So for each nested integer in this list, you'll see if, so first of all, you see if it's integer, yes. Then we'll compare, because if this is an integer, that means that you have already reached the bottom, or you are in the middle of this of the levels. Now, what you need to do here is to compare. So assume you have reached the bottom, which is the first level, but you also have to compare that if you are in the middle or not. So if this part, the max compared to 1, is to see. Okay, so if you're in the middle, you're assigned max to max, so it doesn't change. Now, if n is not an integer, then you'll traverse it again. You'll get the list of this nested integer, and then when you come back, you add 1 because this is the weight of your current level. Well, also you compare max. This is very important. This is a very important part. He doesn't just get the level straight up. He also compares the number of levels to max, which I think that I would have forgot if I wrote it myself. Also, this is the same idea as the previous comparing statement. So this is to see if you're in the middle of the. This is to see if you're in the middle of the level. Now, let's see get sum. So get sum. Now you have the layer or the height. You put in layer and this list, and you pretty much do what you did in the previous method. You traverse it from every. So for every nested integer, you will check if it's an integer or not. Now, if it's an integer, then we'll add we'll add the value of this integer, but also times the weight, and then add it to sum. So else, and then your sum plus equal, and you add. If it's not the integer, if it's a list, then you will go through a depth search. Now, keep that in mind. The difference is the layer is decreasing here because you are going from top to bottom, and at the end you return sum. So very clean solution, and it's very straightforward to understand. It's kind of shameful that I did think of the solution, but wasn't quick enough to implement it. So, well, this is what you get for not practicing LeetCode for over 6 months, or actually even close to a year, right? So, well, I guess just keep practicing. I'll keep on posting more coding challenges or just coding videos. As always, happy coding. See you next time.
I've been flying from town to town.